Hello, my name is Juan Nava. I'm a senior field engineer here at Intrepid. I will be covering how to monitor and simulate LIN. This is one of the new topic I've been requested quite a bit lately. I've had a lot of questions, so I thought today I would actually cover this today. So LIN stands for Local Interconnect Network. It is by far one of the most low-cost, heavily used networks. It's great for extending I/O. It's used for sensors, motors. It's used heavily like in Windows, the motors, the switches, the sunroofs, the steering wheel buttons. So it's used quite a bit. And its use over time hasn't actually reduced. It's actually kind of increased over time. It's just, again, it's it's kind of simple, but it's also very inexpensive. So a typical layer of LIN looks generally like this. It's composed of a master and slaves. Master is the one that happens to control all the communication. Slaves are just devices that are going to respond to that request. Typically, you're going to see a maximum of 15 slaves. A master can be a slave within the network. So I'll explain what that means here momentarily when we talk about the frame within LIN. You will have a maximum of 15 devices, and that's really the limitation is really resistance. Because once you get to a certain level, once you get to beyond a certain level, the system will not work properly because of it'll require a lot more current than it can give. So that's usually your limitation. So it is comprised of battery power, ground, and your link communication. So you can see it's actually quite simple. So you do have other, so if you want to simulate, you can replace like the master, for example, with a red 2, and now I can replace the master and be able to work either with my slave or multiple slaves. So if you're a supplier of one of the modules, you can take one of these devices and simulate the master. All you really need is your LDF file. And I'll walk you through how to set that up towards the end. So three of the use cases that I'll be covering is it's the how to monitor LIN, and then we'll cover how to simulate a master and how to simulate a slave or slaves. So in this case, I can replace the master with one of our devices, and then we can simulate that portion of it. Similarly, we can take one of the slaves away, and then we can simulate that portion as well. So there's also another type of network, which is auto addressing. The wiring is very similar. The only difference here that you'll notice is that between slave 1, you'll have an input and an output, and in slave 2, for example, will also have an input and output. So at the beginning of the communication, they'll be given an address, and then once it gets basically programmed to that address, it opens up its gate and allows communication to the next channel. And it kind of goes down the daisy chain to program all these modules as necessary for the addressing. But very similar. So for this one, I do need a device that has at least one link channel to be able to do as a master, and that would be true of the other one as well. Where it gets a little bit more interesting is when we do the slave, we do need a device that supports a minimum of 2 CAN channels to be able to do this auto addressing, especially if you want to leave the other devices in place to be able to do this. So that is the one limitation of the tool that you'll need for that. Tools that you can use are like a Fire 3, Red 2, Gigastar, value cans. Ultimately, what matters is how many link channels do you need. If you need one, a value can is more than sufficient. If you're using things like on like a bench, a test bench, there may have different voltages between the bench itself and the computer setup. A value can industrial, which I'm not picturing here, can be used for that. If you need at least 2 link channels, you would need like a Red 2, for example. Gigastar will only do 1. But if you need a lot of link channels, the one you can purchase would be like a Fire 3 that has 8 link channels. So in order to kind of figure out how to simulate LIN, we kind of need to understand the frame. So this is not really intended for me to deep dive everything. I just need to tell you just enough how this kind of works. So one of the hardest things to understand about this, at least it was for me when I learned about this, is that the message itself is actually comprised of 2 messages themselves. One part is the header or the master header, and the second part is the slave response. So if you have like a body control module, it'll actually send out this specific header portion of it that tells you there's 3 pieces to it, but part of it tells you the message ID. And that message ID kind of tells the system who needs to respond. So there's a slave that is responding to, say, to message 10, for example. The slave, after it sees the header, will respond with a piece of data. The slave will never respond without the header portion of it because it doesn't know that it needs to communicate. So it will always be two pieces to this frame. Same thing, if the master is also going to respond with the entire message, it'll be the same thing. It just provides the header portion of it, followed by the response itself. It's also the same thing. So it doesn't matter if it's the master providing all the communication for the entire frame, in other words, both responses, or if it's the master and the slave, it's a completely separate slave responding, and that will provide the green portion of it. So there's a couple pieces to the header. The header has this LIN break. The LIN break is really telling the system to kind of wake up. The other one would be your sync byte, and this is the part that syncs up the clocks. In LIN, the slaves don't generally have clocks. They don't have crystals to determine that. So that's usually what makes them kind of inexpensive, because this will kind of help them synchronize to the clock that's on the bus. And then you'll have a piece of data here. That's your ID. So that's your message ID. Now, messages IDs vary between 0 and 3B hex values. And if you see messages that are 3C, 3D, those are diagnostic messages. 3E and 3F are for future forward protocols, or I've never seen those used yet. But the ones you'll normally see is between 0 and 3B. What determines the order of LIN messages? And it really is your schedule table. And this is actually found in this file called an LDF. It's a LIN description file. And this tells you the schedule table. The schedule table is really the part that tells you what modules are going to communicate, in what sequence they're going to communicate, and also tells you what's the how frequently they're going to communicate. So it's extremely deterministic system, because you can determine who's going to talk in what order, and again how frequently you're gonna talk, or how frequently they're gonna talk. Okay, so the thing about the schedule tables, there are files that have so LDFs that have one schedule table, and there are times where they actually have more than one. And it just depends what the system might need to do. So if the system is kind of slow normally and something gets changed, the system can change to the point where these messages become more frequent. So instead of going maybe every 300 milliseconds, for example, they could get down to 100 milliseconds for as an example. Diagnostics tend to be in the 10 millisecond range. Generally, I've never seen anybody run faster than that. But normally, again, you can change the order depending on what it's doing. You know, like diagnostics, they're doing diagnostics, you might stop normal communication and move over just to diagnostics, or there could be a mix of different messages. So the first part we're going to cover is how to monitor LIN. So typically we're going to have a master and a slave. So master could potentially be like an ECM, a BCM, and then the slave could be a motor, could be a sensor. Ultimately the slave doesn't really matter what it is. Typically, this is how you're going to see a typical wiring, though physically it may not always look like this. So here, the master and slave are going to be sharing the LIN communication line. It's a single wire, grounded power. In this case, in my setup here, I have a power supply that provides grounded power to my entire system. And then I'm going to be using a red 2 in order to monitor that data. So again, this is just monitoring. So here, the fact that the messages are two pieces doesn't really matter, because we're just going to monitor. So basically, the master provides half the message, or part of the message, and the LIN part, the slave provides the other half of that message. How do we configure that? So the first thing I'm going to do is I'm going to open up Vehicle Spy to begin this. The next part that I want to do is I want to start loading my LDF file. So the part I'm going to do is I'm going to select my folder that I have specifically created for this, which is LIN. And then from here, what I'm going to do is I'm going to create a platform. A platform is basically a file that's used to reference our database. In this case, it's going to happen to be a LIN database, or LDF. So from here, what I'm going to do is click on this yellow barrel. I can also go to like setup and click the network database. You can see that the icon is the same thing. So it'll get me to the same location. So here, if you never created a database, you'll have this empty, and then you'll see the screen here. So on the top right, I can click Setup Platforms. And then from here, I can click Add to add a new platform. So this is what we're going to use to reference our LDF file. Now, how you name this should be appropriate to what you're working with. Usually, I recommend you put in like model years. If you're working on a specific module, I would probably suggest you put that. So in this case, I'm just going to, for this purpose, I'm just going to call this LIN. And I'm going to click OK. And then one more time, I'm going to click OK. If you accidentally click close, that's okay too. You'll The only difference that if you click close and OK is that if I click OK, it will automatically select my platform. And if I don't, you'll see something like this. And then all you have to do is really just do the drop down and click on LIN. So here to monitor my LIN, I can minimize the scan and go down to where it says LIN. Now here I'm going to use LIN 1. If you're using a Red 2, you're either going to use LIN 1 or LIN 02. In this case, I happen to have everything wired up to LIN 1. From here, I'm going to use this part that says LIN LDF, and I'm going to click Browse. So here I have my LDF file, and then all I have to do now is click Open. Now we see flashing red boxes, and I'm going to click one of them to go ahead and save the changes. Now the next part we need to do is we need to configure our tool to the proper baud rate. So here what we could do, there are two ways to do this. I can simply go to the to my folder where my my LDF is at. And here, what I can do is I can open up my LDF, and I can open this up in the text editor. So like Notepad++. It's a very simple file. Once if you start playing with this, sometimes it's worth learning how the format's in there, but you don't need to. But really, what I really care about is this part here. So assuming my file is correct and it's actually properly updated, I should see the LIN speed here. So here I can see that the LIN speed for this specific system is meant to be 10.41 kilobits per second. Another way to tell what's going on there is that once we load in our file, we can open this LDF tool. So once I click this file or this button, it'll give me the same thing. I can see the format here. But more importantly, here I can go into the master and see how that's configured. I can see the slaves, I can see signals, I can see the frames, so the messages. We can see the schedule table or schedule tables, and then we can see how everything's kind of organized here. If for some reason we see an error, we have a problem with it, we can use this tool to kind of update, make the changes, and fix it. And then we can go ahead and save it and then re-import that file once again. Okay, so there's nothing, I'm going to assume my file does not need to be changed. So I'm going to go ahead and close that. And then the next thing I want to do is I want to go to my Spike Networks messages editor. So here, if I go into database here, this button here, and then on this drop down, I'm going to go minimize CAN and then go down to LIN, and I'm going to click LIN 1. And you can see the symbol here on the left side looks a little bit different than the other ones. So it tells me something's in here. So here's my database. It's 3 messages. One's actually being sent from the master, and then we have 2 messages for each one for each individual slave. So in this case, we have two separate morphs. So here, now that I have the database loaded in, now all I have to do is configure my hardware. So from that, I can either go to setup and do the first option, hardware, or if you see this little icon, it looks like it's actually a circuit board. I can go into click on that button and go into my hardware. So I can go ahead and configure it. So I just got to wait for the window to come up. I'm going to select my device, click connect, in the top left. So here since I am not working with CAN, I'm not going to worry about those. And I'm going to go to my LIN channel 1, which is the one that I'm using. And from here, I can go ahead and select the baud rate that I'm using. Now, if your baud rate is not on this list, you can go ahead and simply type it in. So if I had like 10,000, for example, I can simply type it in. But there's a lot of ones that are being used already that are pre-programmed in our device. So I simply just have to turn that off. When we're simulating, we might have to worry about the master resistor here to turn it on. It's been my experience that you generally don't need it. In all the years that I've been working with LIN, I have never had to turn this on. I believe I take that back. I did have to turn it on one time recently, but out of all the systems I've ever worked on, it's only been a one-time thing. So if for some reason when you're simulating, it doesn't work, try and turn that on to see if that makes a difference. Okay, so here really since I'm not simulating, I'm only monitoring. All I have to do is set up this to be the right baud rate. After I'm happy with what I see, I'm going to click this button that says Write Settings. And then down here, we'll see a confirmation that it wrote the settings. I can go ahead and disconnect or simply close the window. So here now I'm going to go to Spike Networks and Messages. And I'm simply going to go run with transmit or run monitor only. So if everything's properly configured, I should be able to see LIN communication. I'm going to erase this. And on the left side, I'm simply going to click on LIN 01 because I don't want to see those Ethernet messages from my device. And here I now have a system that's actually communicating. So here if I expand on the left side, we see this is the commands. So this is my master module. And I can see it's requesting positions of the motors. And if I go into the responses, I can see the responses of two different slaves. So here in my setup here, I have one device acting as two slaves instead of just being one. It could be just one. Again, depends on what you're simulating. If you only care about your one slave, I would probably just do that, and then you'll have one that's not. It'll show up as a message, but it show without signals not found or unknown message signals. And it's okay to have that. Okay, so here we see that they're responding. So this is what I would do just to monitor. So the next use case is if we want to simulate them as a master. So here we can see that we eliminate all the other stuff, and here we're just going to work with our motors or a motor. So here I have my red 2 that I'm going to use as a master. In this case, the configuration that I have it set up as, it should be perfectly fine, meaning I don't need to go change the baud rate because it's still the same baud rate. It's the same LDF, except you see the system is quite simplified here. So in order to do that, I'm going to stop vehicle spy, and I'm going to close this. And I'm going to actually set this up from scratch again, so you see how that gets set up from scratch. But the idea is very similar. So I'm going to open up vehicle spy. From here, I'm going to click the yellow barrel button to go to this portion. Now, we already have a LIN file, but I'm going to go and create one again, or a new one. I'm going to click Setup Platform. I'm going to add, and then this time I'm going to do LIN underscore master underscore simulate. And I'm going to click OK. And then one more time, OK. Now this part is going to be, the start off is exactly the same thing. I'm going to go to my LIN 1. I'm going to click Browse. I'm going to click on my LDF file and then open. So the part's the same. Clicking the Save Platform Changes, the same thing as before. The only difference now is what we're going to do is we're going to click on this button that says Create Schedule Table, Create Schedule Table Function blocks. So I'm going to click that. Since I'm doing a master, I'm going to select ECU as my masters. If your file is properly defined, it should automatically select it for you. So in this case, it's an ECU. It could potentially be BCM. It could be a different module. In this case, I generically called it ECU. And I'm going to click OK. And then here is OK one more time. So here, if I go into my SPI Networks and Messages Editor, I'm going to click on database, but I'm going to specifically go back again to see the LIN file or the LIN database. And here's my file that I loaded in. Now, if I go to the transmit or received, I should see something specifically in the transmit. So that means this is going to be transmitting something. One thing to notice is that the commands that are being sent by my module, my master module, you'll see that it says master. So here we have a couple of different options that we can select. In this case, vehicle spy, because my file is properly defined, it selects everything properly. But I always want to go back and double check what my settings were. So here my master is that vehicle spy is going to help me simulate the master and slave from the master, meaning there's a message that goes up to the slaves telling them what to do. So in that case, the master means they'll simulate the master response and then the slave response as well. So I'll combine those two. And you notice on these slaves, on these motor responses, we see header only. So vehicle spy in this case is only going to send the header portion of it, meaning the brake, the sync, and the message ID. The rest will have to be filled in by the actual slave. So here we can see that there are three total messages. So here now, if I go to scripting and automation, and I click if I click on function blocks, we'll see that the schedule table automatically got created for me. So in this case, it's basically how it's defined. There's 3 messages, and it gives us the exact sequence, and then we see the spacing between each message. So in this case, we can tell that this is going to be each message will come out every 300 milliseconds. So here, I just need to change a little bit of my setup here, so I get rid of my original master. And now what I'm going to do now is I'm going to go to, here I want to change this from manual to immediate. I don't have to, I can do this. If I leave it at manual, I can start this from here. And then from here, what I want to do is I want to go to SPI Networks. Okay, why is my computer now suddenly slow? Okay. Come on, cooperate. Okay, I don't know what's going on here, but okay, so here I'm gonna click play, and now I'm gonna go and erase everything so I can get rid of stuff I don't need. And I'm gonna specifically select LIN 1 so I don't get extra stuff. And then here we'll see that we see green dots. At the very bottom here, I forgot to mention this, we want to change this over to LIN. So it gives us the proper columns for LIN. But here we'll notice that we have two green dots on the first line. One of them is TXH, so it's transmitting the header, and then TXS is transmitting the slave portion of it. So in other words, this one message at the very top is transmitting both portions of it. So here, if I expand this out, I can now see that there's my signals that are being sent to the motors. And then the motors, I can see that they're responding because I see actual data in within my message. I can see the signals being populated. So normally, if this wasn't working properly, we would see that these signals here wouldn't get populated. It would just say like unknown signal. So here we're actually simulating something. Now, if I go into, like, for example, my Spy Networks and then TX panel, I can go into my commands, and now I can go and say, hey, go ahead and change this over to a different value. And I can simply go to like position 3. So now if I go into my messages here, I see it says position 3, and my slave response saying that it moved to position 3. So here it would be a very, very basic simulation. If I needed to make it more complex, of course, I can put this into a graphical panel. So here what I'm going to do is I'm going to go to, oops, I opened up the wrong window. I'm going to go to measurement and then graphical panels. And here I'm not going to do anything complicated. I'm going to keep it real simple. I'm going to do this drop down box. And then on the right side, I'm going to click on signal. I'm going to go to TX because that's the one I'm controlling. You can see it's already selected for me. And I specifically want to select motor 1 request. Double click OK. And then I'm going to go to signal list here. Load from message, click on the button that says load from signal. And it'll give me the options that are for that. Click OK. And then I can duplicate this or I can recopy it. And then I can do the same thing for the next motor. So here I'm going to click on signal. But this time what I'm going to do is I'm going to go to the second signal. And I can see that updated. And click OK. So there's a lot of things I can do here. So here I'm going to click the ABC. And so I don't forget what it is, I can go and change the caption. And on caption, I can say this is motor 1 request. And then I'm going to make this bigger or longer. And if for some reason the letters are not big enough, I can go to fonts. And I can go and change that to maybe, let's go with 10 maybe. Yeah, might be good enough. Maybe 12. No, let's go with 10. And then from here, I'm going to copy with my keyboard, Control-C, Control-V. And then the other one, I'm just going to rename to be motor 2. So now if I go and lock in my graphical panel by clicking this lock button at the very bottom, now I'm going to move this graphical panel over to the left side. And my computer, just cooperate. So now I can go to my messages view now. And now I can go ahead and change these from over here now instead of doing them through the other panel. So I can see a request, and I can see the response from the slave. And I can do the same thing from the other one. And we can say they requested it, and then the slave response with the proper portion of it. So quite simple. If I didn't want to be in messages view, what I could potentially do is I can go into the request here, and I'm going to unlock this. And potentially what I could do is I can take this grid here, and then I can just put in the signal, click on signal group, and I'm going to click on database. And then I can see the motor position for motor 1. And then double click on motor position for motor 2, click OK. And now I should be able to see everything from here now. So I'm going to lock this down so I can work with this. So I will request 2. We can say it goes to 2. I can just change this to 0. So here I can do the same thing as I was doing it before Again, just a different way to kind of filter what we did. Okay, so that's it for the master simulation. So what do we do for the slave? So here what I'm going to do is I'm going to close this one more time, and I'm going to actually restart this again from scratch. Okay, so now we're going to cover our last use case. So we went from simulating the master. Now we're going to simulate the slave. So just my roles changed for my ECUs here that I'm using. So now my red 2 now is going to be the slave, and my new ECU 12 is going to be my master. So I'm going to open up Vehicle Spy again and create again something from scratch. So here what I'm going to do is click the yellow barrel, click Setup, Add, and I'm going to name this platform LIN slave underscore simulation. Click OK. Click OK one more time. Like before, reduce the can, go down to LIN, select LIN01, browse. I'm going to select my LDF just like before. Click on one of the flashing red boxes. I save the changes. And this time I'm going to start by going to Messages View. I'm going to go run with transmit. So here now I'm going to filter just on LIN1, because otherwise I'll get some extra noise. And I'm going to erase the buffer because I want to get rid of old stuff. So here we can see that the master sending a position request. So I script that I wrote real simple to kind of send that, just change that periodically. And here we can see that the slaves are now responding. But you can see part of the message here. So we're seeing the header really, but we're not seeing the payload or the second part that the slave responds to. So therefore we see signal not present. So in order to fix that, I'm going to stop Vehicle Spy. I'm going to go Spy Networks, Messages Editor. I'm going to go into LIN, and I'm going to click Database. And then these two signals, or these two messages, I'm going to copy over to transmit. Now, if I'm only responsible for one of these modules, I will only copy the one that I care about. I wouldn't copy all of them, but in this case, I'm going to simulate both of them. And now I'm going to go to transmit. Now I see both of them. Now this part here is extremely important what you see here, because I am going to simulate the slave. I want this to say slave. So once again, master is the one that simulates the master header and the slave response. Slave only does the slave response. Break only is where it wakes up the bus. And then header only is when we want to simulate the master, but we want the slave to respond. So in this case, I want the slave to respond. In this case, sorry, I want our device to respond as a slave. So here now, if I go into Spy Networks, TX panel, we now see our signals or messages here. And I'm going to change these to be maybe 100 milliseconds, even though technically this is faster than I need them to be. Let's go ahead and start this up. I'm going to erase the buffer one more time. And now we see that the master hasn't really changed. But when I expand the slave, we see a green dot, but only on the TXS. So to transmit the slave portion of it. And now we see that the unknown signals was gone now, and it's actually filling up with some data. Here, in order for me to actually respond to what the master is requesting, I'll need to create a script. And for the sake of this, I'm going to create a real simple script. I'm going to go Spy Networks. I'm going to go Spy Script and Automation Function Blocks. I'm going to click Script. And then I'm going to call this Motor 1 Response. So here what I'm going to do is I'm going to do an if statement. And I'm going to look at the data that's being received for ECU commands. I'm going to specifically look at motor 1. And here I can go and click like equal. And I can do position 3. I'm going to double click. Click OK. And then I'm going to do this for a couple more lines. So I'm going to copy this line. And then I'm going to change this to else if. And I'm going to change this to be, well, 2 should be enough in this case. I can go into this and do the, to this part here. So I can use this portion of it. But let's do that instead. And then we're going to do double click, click OK. I'm going to copy this line again, paste it. And this time I'm going to do the other command. We want, so we did 3, 2, now we're going to do 1. And the last one we're going to do else. So I don't need to call it the last one to say it's 0. and an end if. So every if that you begin with needs to end with an end if. And now we're going to change what we're going to transmit. We're going to do set value. And then of the messages we're going to transmit, I'm going to select motor response, motor position. And this is going to be value 3. So 3 should be enough because I know that's 3. And I'm going to be lazy and I'm going to do some copying here. Click OK. And I'm going to paste again. And this one will be 0. So basically what I'm saying here is that whenever there's a value 3, I want to output 3. Whenever there's this request of 2, I'll put a 2. Same thing with a 1, I'll put a 1. Else, if none of these match, we want to output a 0. So I don't specifically need to call out 0 to say that it needs to be, because I'm just using it as a default state. And then if I don't do that, if I don't put into wait any delays, this will run really quickly. So here I'm just going to wait for, and what do I have this up as 100 milliseconds? So I'm going to call this wait for. I'm going to put this at 100 milliseconds so it doesn't run faster than it needs to be. And now we're going to go hopefully run this immediately. So I'm going to click play. If I did this correctly, we should see that whenever 1 is requested, 2 will be appropriate. So as the first top one changes, this will change to purple. So now we have a basic simulation to my master. So if I'm working with a master, I might want to do this something simple like this. Depending on the what you're doing, you might need to create more complex simulations, but usually this might be enough. So here, if I wanted to duplicate this response, I can say copy, paste, and now I can do a motor to response simulation. And on this one, I have to redo quite a bit of it. So here, what I'm going to do is I'm going to go to message 2 or motor 2, and I'm going to change position 2. Now this changed, so I don't have to do this again. I'm going to just copy the whole line, and I'm going to go back here and repaste this on all these other lines. So I'm kind of showing you the way to kind of quickly do some of these things. And here, I'm going to go to LIN database, and this one's going to be the command for motor 2. So here I'm going to equal to 3. I'm going to specifically copy this portion here. So I can do this here from here. And here what I'm going to do is I'm just going to copy the left side of the equal sign. Oops. Or paste. Okay, so motor 2, that looks good, position. And if I did everything correctly, the other one should now respond too. So essentially it should be the same values. And we see they're responding now. So now I created 2 real simple simulations. So if you have any questions, you can always ping us. If you have any technical support questions, you can ping us directly. If you have any sales questions, you can always ping us as well. If you're struggling with something, maybe that I didn't cover here, don't be afraid to reach out to us. We're here to hope to support you. So don't be afraid. There's no bad questions. I always get the it's a dumb question. No, there's no dumb questions. If you don't know, you don't understand something, ping us. Don't waste a bunch of time. If you spend a day on it, that's okay. But if you're gonna spend 2 days or 3 days on something that you don't understand, just contact us. We can definitely walk you through a lot of different things. So hopefully you find this helpful. If you have any questions, you can always send us these questions, and don't be afraid to reach out if you have any questions. Thank you so much, and I will post other videos in the future.